I'm going live. Hi, everyone. Thanks so much for joining us. We will go ahead and actually dive right in. I'll do a quick little introduction here while we have some more folks joining the call. My name's Kelly. I'm from the Dewey team, and I'm so excited to welcome you to today's seminar. Before we get started, I'll do a little bit of housekeeping. So the number one question always is, will we be recording this session? And Taylor, if you go to the next slide, the answer is yes. We'll share a recording of this session. We'll also share the slides, which have a bunch of little tips um, Taylor's put together. And yeah, feel free to share this information with other researchers in your network. You can share the recording link. This resource is yours. So in addition, I just want to encourage everyone to ask questions throughout the session today. I'll be monitoring the chat and the Q&A, and I'll surface things to Taylor as we go. We also will have some time for questions at the end. The last thing I'll say on kind of housekeeping is we are throwing a lot of these seminars in the coming weeks, and we'd love your ideas. So any topic that you want covered, any specific data set you want us to dive into or partner you want us to feature, drop that in the chat to us or just send us a direct email. And we want to make sure that we are creating the content that you guys find most useful. So if you're new to Dewey, we are a platform that is specifically for academic researchers. We have hundreds of data sets included in our subscription, and then additional that can be unlocked with a direct license for our institutional subscribers. You can create a login for free with your .edu email at deweydata.io. So feel free to do that and kind of play along with Taylor as she goes. And with that, I'm so excited to introduce Taylor today to lead the session. Um, Taylor's new to the Dewey team. You'll see an old headshot over here, but she has that perfect set of skills that is both an education background and a data heavy background. So I say she has a very particular set of skills. She also has a PhD of her own in experimental psychology. And I don't want to get these details wrong because they are impressive. Uh, but in addition to her own PhD, uh, Taylor has her own hands-on teaching experience as a tutor at UC Davis, a teaching assistant at UC San Diego, a lecturer at both UCSD and USD. She's designed and taught lower and upper division coursework, including a stats and research methods course, which is a perfect fit for Dewey. And then most recently, before joining our team, she was diving deeper into her data science skills as a freelance data analyst. So now she joins us as our research and growth lead, and I'm so excited to hand it over for today's session on big data. Go ahead, Taylor.
Thanks so much, Kelly. I'm excited to jump into navigating big data today. So everyone, thanks for joining. Happy summer. Great time to start some new projects and learn some new skills. So let's dive in. So today we're going to talk about navigating big data workflows. So a couple notes about today's seminar and how it's framed. So first of all, this is mostly for Dewey users. So best practices about getting big data sets from Dewey specifically. However, we're going to be talking about a lot of concepts and tools for working with big data in general. So whether you're new to Dewey, you've been using it for a while, or maybe you're not even a Dewey user and just interested in big data, I think you'll find today pretty helpful. Also, today we're framing this big data workflow around working locally on your laptop. So this is working without the cloud, working without access to maybe a university computing cluster. Those might be topics for a future seminar. If you're interested, just let us know. But today we're really talking about how to handle those big data sets on your laptop. And then also today is for any technical level. Again, like Kelly said, I've been a stats teacher and tutor for many years now. I love talking about these things. If anything is not clear, ask your questions. Kelly, feel free to interrupt me throughout the talk if anything comes up. Happy to dive in further. And then if you stick around at the end, we'll answer any unanswered questions and I can dive into maybe some demos and anything that's useful. So just to start out with, I'd love to know who's joining us today. And quickly, have you downloaded data from Dewey before? just so I can get a sense of everybody's sort of experience level with the platform. So I'll give you a second to answer that.
Cool. Looks like we have pretty mixed reviews here. So I'll end the poll for now just to keep us going, but about 58-42 split.
Great. That's wonderful.
So more people have, but a good mix.
Cool. So a bit of what we'll cover today is a lot of the tools and best practices for working with big data locally on your computer. But my main goal for you today is, yes, I want to give you the practical tools. I'm going to give you some copy-paste code to get you started. But I also hope you leave today with some of the big picture. Why do I think both are valuable? Well, copy-pasting code is one thing. I've often found it can lead to copy-pasting error messages, and that often feels like you're sort of muddling through docs. And as we're working with these big complex data sets, our workflows can get a bit more complex. So today I'm hoping to give you maybe a better understanding of the process as a whole. So the when and the why and the where to use these different tools more confidently so that you can build a workflow for your specific research project, and then you can confidently repeat it or alter it and master it depending on your data needs for that research project. So with that, let's talk a little bit about why is big data different? Why is big data such a constraint for some research projects? Well, the main thing is that these large commercial data sets, being 50 to 500 gigabytes sometimes, just simply won't fit on your laptop. And especially you're going to run into memory and RAM limits. Your workflow looks different. You can't simply open these files in Excel to inspect the variables. And generally your tools are going to crash or stall out when trying to do simple processes. So one of the main things we're going to talk about today is that often you don't actually need the whole data set. You might just need a specific slice of it. So how do you reach in and pull out that slice without needing to process or download that whole data set? So we'll talk about a lot of those and different pathways depending on what your needs are for your research project. So let's start with looking at the big picture. So navigating your journey from finding the right data set that you need all the way down to working with it and building your analysis workflow. So this first layer is really about setting yourself up for success. So from discovery to finding which data set is right for your research project, I'll walk through some of the features that are built into the Dewey platform itself that really set yourself up for success throughout your workflow going forward. And these are really key for working with big data sets. So I'll walk through some of those next. And then from there, we'll talk about some different paths depending on the size of your data set. And so that's really going to change what your workflow looks like depending on how big your data set is, and that's going to determine which path. So we'll talk about each of these. But starting off with how to set yourself up for success just on the Dewey platform. So when navigating these big data sets, it can be a bit tricky to find and evaluate the data that you need. Like I said, you typically can't just open this in Excel and evaluate the variables. So using these features is really more efficient when working with big data, and it's going to save you a lot of headaches later down the road. So the first one that I personally use a lot when working with our data sets is the AI search and the Dewey MCP. So when you're looking for the data set that you need, on Dewey we've got hundreds, and so sometimes you might not even know which data sets or variables might be useful to your research. So the AI search really helps make data discovery a lot more easy to access. Um, and this is actually fairly new to Dewey itself. So if you haven't checked out the AI search yet, uh, feel free to give it a try. But Kelly, can you see the platform now? Am I still sharing that?
Yep.
Perfect. Yeah, so it's in this new Discovery tab on Dewey, and you can type in natural language questions to find different data sets that maybe you didn't know applied to your research. And then the other thing that I also find super useful is the MCP. An MCP is just a model context protocol, which was open sourced by Anthropic just a few years ago. You've probably seen a lot of different platforms have them now. You can think of it as basically just a bridge between your apps and tools. So basically, you can connect your Chat GPT or Claude directly to Dewey's documentation. And so I find this super helpful when you can ask Claude directly about different data sets. You can ask about variable schema. You can even ask about different collection methodology, basically anything you'd find in our docs themselves. So this can be really, really helpful for evaluating a data set to see if it's right for your research project. The other thing I'll highly recommend is to always download that sample. So you can download a sample of any data set by clicking this get sample, and that's just going to download the first 100 rows. And so then you can really inspect the variables, test out your code, do some error handling on that small amount of data, and then scale up after that. So I really find that 100 row sample is really helpful. So a couple other things, and since we've got about half the group here has already downloaded data from Dewey before, I'll kind of skip through these now, but if you're new to Dewey and you'd like to see some of these demoed at the end, stick around and I can walk through those. But basically, you can filter and customize data sets right in the Dewey platform. And so this is going to help sort of prune and narrow down the data to be exactly what you need. So this really can shrink that file size significantly before you even start working with the data. And then I'll also just point out, by saving these sort of customized data sets to a project, this is going to be really advantageous for collaboration. You can add teammates to the project so that you can all access the same data set. And this is really helpful for replication. So tracking your progress and replicating workflows throughout your team members. And then finally, once you have the data set that you know you want to work with, you've saved it to a project, let's talk about different download methods and of how you're going to actually get that data and start working with it. So before we get into the nitty-gritty, I would love to know everyone's familiarity and experience level with some of these different tools. So these are by no means equivalents of each other. These are just some of the different things we're going to be talking through today, and I'd just love to know, have you worked with these before? If not, that's totally fine. And maybe you have a preference for some over others. So go ahead and just click any that you've had experience working with prior. And Kelly, do you know oh, perfect. Okay, great. So we've got a lot of Python users, just almost as many R users. And looks like we've got a fair amount of experience with some of the other tools, but not everyone, so that's great. So we'll sort of be diving into what each of these different tools do, but more specifically, maybe when, why, and where you would use them. So starting off with, on path A, this is for the smallest data sets. And so I'm really mostly including this here as a base reference of maybe what you're used to. But on Dewey, if your data set is less than 2 GB, then we'll give you the option just to download this straight from the browser. So when you go and click that Get Data, it'll give you the option to download maybe some zipped CSV files. Those are going to land right in your downloads folder, and then you can put them in whichever file on your computer you want, and you'll load that right into your analysis tool with a couple lines of code. So this is sort of the path for your typical data set. It's fast to download, it's fast to process. If you're new to programming, this is a great place to start and play around with some exploratory data analysis. Oftentimes as well, if you use those filters within the Dewey platform itself to customize your data set, the data you actually need might fall within this range and be small enough to work with through this path. I'll also point out that even if you're not a Dewey user, we're going to be adding some free data sets to the platform soon. So that's another great way to sort of play around with working with and downloading data and starting to explore some data analysis methods. So this is sort of our reference point, maybe what we're used to. So what starts to change as the data set gets a lot larger? So as the data set gets larger, our workflows are going to need to change. So paths B and C are really going to be similar in that we're running into either storage limits, memory limits, or both. And so we're going to talk about how that workflow changes here. The first main thing that's going to differ is our download method. So these files are too big to simply click that download straight from the browser. So we're going to be utilizing bulk API downloading. So we'll talk a little bit about what that is. And the second thing that's going to differ here is the file format. So here we're going to be working with Parquet. I saw there was some familiarity with that. So we'll talk a little bit about what Parquet is, how that differs from CSVs, and why it's really efficient for working with big data. So path B looks like downloading the data through API, the files land on your disk, and then we're going to need some new tools to filter and work with that more efficiently. So this path is for maybe the entire data set fits on your laptop. So kind of talking between the 2, maybe 10 GB range, but that's still a massive amount of data, and it's going to be really slow to work with or access and process in your analyses. So maybe for a research project, you actually need the whole data set, or at least you need a large amount of that data set, but maybe you plan to analyze it in specific ways. So querying it in chunks or stages, but still doing that, those sort of aggregations and analyses locally on your computer. So the real constraint here maybe isn't storage, it's more memory, RAM, and processing. So first, let's walk through the download stage. So downloading via bulk API, what does that mean? So we're going to do this with Dewey Client, and if you've downloaded data from Dewey before, you might have read about Dewey Client in our docs, but what exactly is that? It's essentially some pre-baked code that can work in whichever language you prefer, and it's going to work to download your specific data from Dewey onto your laptop via API. What's API? API stands for Application Programming Interface, and the best way to think of it is basically like your waiter at a restaurant. So you're going to give it your order, it's going to run and get your files and bring them back to you. So other ways you might have worked with APIs without realizing it is anytime a website asks you to log in with Google, so that's actually using Google's API to verify your identity without that website ever actually seeing your Google password. So weather apps also work similarly. They're going to use APIs to pull your specific location weather data to give you your local forecast. So the Dewey client is going to work the same way. And essentially you need to give it two things. So the first thing you're going to give it is your API key. And that's just exactly that. It's your key to the building. And so that's what's going to authenticate your access to these data sets. Again, if you haven't downloaded data from Dewey before, if you stick around at the end, I can demo exactly where to find this. But this is going to be issued to you the first time you download data, and that's sort of your permanent key. So I'd also recommend sort of saving that kind of permanently, either in your terminal, or you could also save it permanently to your R environment. And this is just going to give you that authenticated access. The second piece you're going to give the Dewey client is your API URL or your project ID. So your project ID is basically your order. So you're telling it exactly which files to grab, which data set to pull. And so this is going to be from your saved project, and it can be that customized data set that you save. So the way this works is it's going to authenticate your access, pull the exact file or order that you want, and then it's going to run the multi-threaded download for you. And what that means is it's basically splitting the data into chunks so that it can run the download in parallel. And so with big data, this is really key, and it's going to be a lot faster. And it also does some error handling for you. So it's going to detect common errors like connection drops or rate limits, file size, and it's going to sort of fix and rerun those automatically. So this is what that code looks like. You can do this straight in your terminal, and this is really whether you have a Windows or a Mac. It's running Python in the background, but you don't actually need to download Python. This is going to run through a temporary isolated environment, so that basically just means you don't need to do any installations to let this run. So you just open your terminal, you plug in this one line of code, you'll plug in your API key and your project ID, and then it's going to download those files straight to your computer. If you prefer, you can also set a directory so you can tell it exactly where to download these files, and you can also add some extra filters to that data to prune it and slice it even more by partitioning by date. Also, if you prefer to work in R, we've also got this great R package called Dewey R that lets you download again with just one line of code. So again, you'll plug in your API key and your project ID. You can specify where you want this to download on your computer, and then you can also add some date filters if you like. Okay, I'll pause there. Kelly, do we have any questions so far on the Dewey client or maybe how API works?
Not on the Dewey client. I answered one really quickly about the MCP and that access, but I think you're good to keep going.
Great. Yeah, I do find that MCP very helpful. Okay, so we've got some files downloaded on our computer. And maybe for a reference point, the other day I downloaded a 9 gigabyte file that took about 11 minutes to download. So these are still really massive amounts of data. And so processing and loading them is, we're going to need some updated tools to be able to handle these large amounts of data a lot more efficiently. So next we're going to talk about DuckDB, which is sort of built to be able to handle these big data sets and let you filter, aggregate, and query those files that are living locally on your computer. So I will say that DuckDB was open sourced by some database architecture researchers from the Netherlands. It was released in 2019. And I say that just to include the adorable story that they named this after their actual pet duck named Wilbur. Partially, they said, because ducks not only are great navigating both land and water, sort of showing the versatility of this database management system, but also that they eat everything, apparently. Um, Also showing the versatility of this program. So DuckDB, named after Wilbur. And later we'll talk a little bit about polars as well. But basically, both of these are going to take advantage of some key data infrastructure elements that make processing big data more efficient. So the first one is file format. So we'll talk a little bit about the difference between CSV and Parquet files. Parquet files are binary compressed and columnar rather than CSVs, which are text-based and tabular. So I'll show a visual next to show what the sort of that column-based storage looks like. But basically, this is going to make querying and analyses a lot faster and a lot more efficient. Also, DuckDB and polars take advantage of what we call lazy loading. And the best way to think of this is kind of like the difference between streaming versus downloading a movie on Netflix. So DuckDB is going to sort of evaluate your whole plan and then execute it in chunks. So sort of like that streaming the data in so that it's never actually holding the full data set in memory. So a little bit about why Parquet is faster for big data. So I did this little animation to sort of show the difference between a CSV and a Parquet and how it is that your computer is reading these files when you're pulling specific columns for analyses or joins. So the CSV is what we call row-based. And so when you pull a specific column, it has to go through each of those rows to be able to pull out the right data. So essentially, it's always going to be reading the entire file. The benefit of a Parquet is it's column-based storage. So when you're pulling that one column, it's really only looking at that one column. And so it's going to work a lot more quickly and a lot more efficiently. And I can share this with anyone if you're interested. So whether or not that makes sense, I always find things are a bit easier to understand if I can see some sort of visual. But the main point here is that Parquet is ideal for these big, large data structures because of this column-based storage, but also because it's compressed. And so you're saving not only space, but also processing speed. And small side note about Parquet, this was named after the French, if you've seen Parquet wood flooring, it's when they sort of have those intricate lattice designs in hardwood flooring, which is basically just to say that you've got sort of this metadata level, which allows you to compress and then expand the data. I like how people name these different programs. And I think they do it cleverly for how that data, for what the purpose of these different programs are. So if that helps you remember, great. If not, don't worry about it. Okay, so let's get into the code a little bit here. Again, this is copy-paste code, but here it's going to also depend on your specific data set. So for this one, maybe I want to pull data specifically for San Diego. But you could also, pull for different NAICS codes, maybe pull certain company data, and sort of specify your filters depending on your research project. But so this is going to be taking advantage of that lazy loading. It's going to look at your plan and then execute that in chunks so that you can comfortably run these sort of aggregations and joins on these really large data sets without maximizing your RAM. So one thing to note here is that polars is also really useful in this sort of querying files more efficiently. because it's also going to work with Parquet and lazy evaluation. And Polars also works in both R or Python, and is going to be an efficient option for a lot more of your data analysis. Okay, so path C is going to look fairly similar. The difference here is we're going to filter first before we download. And so this is the case when maybe the source data is too big for the disk. And so here only your filtered results are actually going to land on your computer. And so kind of the key caveat here is that your filtered results still need to be able to fit on your disk. Again, that capacity is still pretty large, and we're going to utilize these features of DuckDB to do that more efficiently. So this looks somewhat different because we're going to basically use this lazy loading and sort of streaming download to filter remotely over HTTP before anything actually lands on our computer. So you're going to send your filter commands basically with the API so that it's only pulling what you need and bringing that to your computer. And then the copy to is actually what puts that on your computer. Some of the benefits for this path is that it's a bit more flexible. You can specify, depending on the data set that you're using, you can specify more exact variable filters than maybe are offered in those user interface filters. And again, this is taking advantage of the Parquet efficiency to only pull what you need. A couple tips I'll point out here for best practices when using this method. First is to restrict any wildcard querying you're doing. So frame those wildcard queries maybe within hard partitions so that you're not accidentally having to scan the entire data set. And then also Hive partitioning, so you can bring these files in chunks and nested folders so that you're not storing this large data set in one file, but several different files that make sense either by year or by city or what have you. Another tip is to set some memory ceiling caps. So say you're working on a 16 gigabyte laptop, maybe set the ceiling cap at 12 gigabytes so that you don't accidentally crash. And again, this works in Python or R. Again, we're going to be downloading through API, so you use that API key and that project ID, or sometimes it's called data ID, project ID, same thing. You can, again, add some date partitions and specify, depending on your data set, exactly which selected chunks of this data you're going to want to look at. The R version of this also works through that Dewey R package. And then from there, you can also utilize either Polars. I would recommend Polars over Pandas for this to start doing your analyses and lazy joins. So overall, this is sort of a summary of which path to choose depending on the size of your data set and the needs of your research project. Paths A and B are best when you need that full data set on your disk. Path C is for when maybe that data set's too big for your disk, and so you're going to filter before you download. Paths B and C are mostly going to work in Parquet. If the file is small enough, then you can still work in CSV. And Yeah, the main difference here is whether you need that full data set for your research project. Path B is probably going to be the most efficient, and then using DuckDB to query and analyze that more efficiently, maybe in chunks. Um, Whereas for Path C, you're going to utilize DuckDB to do that filtration process right from the start. Okay, so that's sort of the overview. I went over time a little bit, but I'm happy to pause here and answer some questions. I'd also just like to point out that we always love your feedback. For maybe some more specific technical questions, always feel free to check out our discussions page. Feel free to even copy and paste your code and error messages, and that will help us sort of troubleshoot with you. Um,
Two
yeah, I'll
quick,
pause there.
two quick questions came in.
Yeah,
One is, I think you had mentioned pandas. Is
yeah,
the transition to from pandas to polars easy, or do you have any tips for that?
yeah. So I would say that transition is definitely manageable. Polars is definitely going to be more efficient for working with these large data sets. Um, and yeah, whether you're working in Python or in R, um, that the working with Parquet and the lazy loading are definitely going to be time savers. And so I can share some blogs and resources if you want to follow up with me afterwards. But that's definitely a transition that lots of people do, and it's I would definitely recommend it when you're working with these really larger data sets. It's just going to improve your workflow a lot.
Perfect. And then the other one's a little more specific to Dewey, so you might
Yeah.
need to jump to the platform, but it seems like how big your file is really drives what you should do. Where can I see file size on Dewey?
Yeah, great question. So, and for anyone that hasn't downloaded data from Dewey before, um, this is pretty helpful. But basically, so once you save a data set to a project, um, we'll go to this one. These customized data sets are going to show up in your project, and then you'll go to this Get Data button. And so last week I was doing some exploring of football salary data because World Cup. And these data sets are actually quite small. So when you go to click data, it'll tell you how many rows, how many columns, and the file size. So this file is actually pretty small. So this gives me the option to just download that CSV straight from the browser. Um, and then once your file size gets a little larger, that one's still pretty small. Then you're going to want to use this bulk API method. So this file is 9 megabytes. So this is that project ID or API URL. So this is going to direct that Dewey client or that API download to this specific data set. So this is like your menu order. And then if you need to issue a new key, you can issue a new API key here. And then also if you want to just download, this is the code that I showed earlier. You would just need to replace your actual API key. But this has the project ID baked in, and you would just put this one line of code right into your terminal to download that data set. So yeah, you can see the file size right here, and then you've got your different options.
Awesome. I think that's the only question for now. We will be sharing the recording, and I know this is on Taylor's slide, but I do want to do one more plug for the discussions space in Dewey. If you have any follow-up questions or specific questions that pertain to your research, that's the spot. It's directly linked in the Dewey product as well to just go and drop us a line and our team can get back to you.
Yeah, and if anyone's still around, I would love to know. This is our sort of the kickoff of our summer seminar series, so If there's any topics that you're interested in learning more about, um, please let us know, and we would love uh, to build these seminars about what would help you most, or just what you might be interested in.
Awesome. It looks like we're getting some good responses here, but I want to leave it open to capture any last answers that come in. And we're just about at time. So thank you everyone for joining, and thank you, Taylor. I learned a lot and I like all of the little anecdotes that makes it easy to remember with the wood floors and the ducks and the Netflix references. Um, so yeah, we look forward to seeing everyone next time. And again, this recording will be shared and please feel free to pass it along.
Yeah, thanks so much, everyone. And as you start working through some of this code yourself, always feel free to reach out with questions.
Well, thank you.